Alright, so in this video we're going to be solving quadratics by factoring when the term is not a 1. Alright, so we're given for number 1, solve the equation 3x squared minus 16x minus 7 is equivalent to 5. Alright, so let's lay out the steps on the side for this. The first step would be to get the formation of ax squared plus bx plus c is equivalent to nothing. All right, so this just means that all your terms should be on your left-hand side of your equation, and the right should be a 0. So to get that form for number 1, where you want to get rid of the 5, the inverse of 5 would be take away 5 on both of your sides, and that gives you a 0 on the right. We have on the left 3x squared minus 16x, and then negative 7 minus 5 gives you a negative 12. Right, so once we have that form, then step 2 would be to factor. And in this case, the term is not a 1. So you want to satisfy the conditions that get two numbers that multiply your AC term. And at the same time, these two numbers have to add to your B term. All right, so in this case, you want to get two numbers that multiply to AC. And AC would be 3 times negative 12. And that's a negative 36. At the same time, these two numbers have to add to your B term, which is a negative 16. Okay. So these two factors would be an 18 and 2. And 18 should be negative for it to work out. All right, so bring down the first term as is, 3x squared, and then break up your middle term, the bx term, into negative 18x's plus 2x's. All right, so these two terms were the factors that we found in this condition over here, negative 18 and positive 2. Okay, so, and then bring down your last term as is. This is factoring by grouping. All right, so the first two terms have a common factor of 3x, and 3x times x gives you a 3x squared. 3x times negative 6 gives you a negative 18x. And these two terms have a common factor of positive 2. So 2 times x gives you a 2x, and 2 times negative 6 gives you a negative 12. All right, and this is your common factor, which is your first factor for the quadratic. And the other one would be whatever is left, meaning 3x plus 2. All right, so step 3, once you factor everything, then you want to set both factors equal to 0. Okay, so either x minus 6, which is your first factor, would be equivalent to 0, or 3x plus 2 would be equivalent to 0. And you want to solve both individual equations to get the two values of x. If you were to add 6 for this, then you end up with an x value of 6. And for the other equation, if you were to subtract away 2 first, then that gives you a 3x value of negative 2. And then divide by 3, and that leaves you with an x value of negative 2/3. All right, so these would be the two solutions for this quadratic, 6 and negative 2/3. And that's basically it. Solving by factoring when the term is a 1 versus not a 1. The only difference would be the factoring process. If the term is not a 1, then it's just a longer process to factor. Or if the term is a 1, then the factoring process would be a bit shorter. But both ideas are the same, that once you have everything to be factored in this step over here, then you set both of your factors equal to 0 and solve both individual equations. Okay, so now number 2, just some more practice for this. Say we're given solve 6x squared minus 13x plus 3 is equivalent to negative 3. All right, so again, the first step should be to bring everything over to one side. So let's add 3 on both of our sides to get rid of that negative 3, which leaves you with a 0 on the right. And we have on the left a 6x squared as is minus 13x. And then 3 plus 3 gives you a 6. Okay, so always check if you can divide every single term, the 6x squared, the 13x, and the 6. If every term is divisible by a common factor, then do so. That just makes everything easier to factor, right? So, but in this case, we cannot divide everything by a common factor. So you want to satisfy the condition that get two numbers that multiply your AC term of 6 times 6, and that would be a 36. At the same time, these numbers have to add to your B term, which is a negative 13. Okay, so these numbers would be a 9 and 4, and both of them have to be negative for the conditions to be satisfied. So bring down the first term as is, and then break up the negative 13x into negative 9x's minus 4x's, and then bring down as is your positive 6, and that would be equivalent to 0. All right, so let's factor by grouping. The first two terms have a common factor of 3x. So 3x times 2x gives you a 6x squared, and 3x times negative 3 gives you a negative 9x. And these two terms have a common factor of negative 2. All right, so negative 2 times 2x gives you a negative 4x, and negative 2 times negative 3 gives you a positive 6. Don't just bring down that symbol as is, right? Double check what's happening. Negative times negative gives you an overall positive, and that's going to be, you maintain the value of your expression. And the first factor would be 2x minus 3. The other factor would be whatever is left over, which is a 3x minus 2. And that would be the factorization of our quadratic. And once you have everything to be factored, you're basically done. You want to then set both of your factors, 2x minus 3 or 3x minus 2. You want to set both of them equal to 0 and solve both individual equations, which if you add 3, then 2x should be a 3, and then divide by 2 and x should be a 2/3. The intermediate steps don't have to be shown if you know how to solve two-step equations. Same thing for this, we add 2 first, and 3x should be a 2, and then divide by 3, and x should be a 2/3. All right, so these would be the two solutions for our quadratic, either 3/2 or 2/3. All right, which takes us to number 3. Say we're given solve 2x squared is equivalent to 40 minus 11x. All right, so again, bring every term over to one side in the form of ax squared plus bx plus c. So let's first add 11x to get rid of the x's, and at the same time you want to subtract away 40 to get rid of the constants. And these are not like terms, so they cannot be combined, right? This is pretty much a whole quadratic. We have a 2x squared, and then plus 11x minus 40 is equivalent to 0. All right, so once you have your proper form, we can then factor, right? So let's get two numbers that multiply to AC, which AC in this case would be a twice negative 40, and that's a negative 80. At the same time, they have to add to your B term, which is in this case an 11. Okay, so these two numbers would be I believe 16 and 5. All right, so it might take some time to get the numbers, but you get them eventually. And 5 should be negative for both conditions to work out. So bring down the first term as is, 2x squared, and then we have a plus 16x, and then a minus 5x. Right, so these two numbers came from these numbers right there, 16 and negative 5. And then bring down your c term as is, which should be equivalent to 0. And then the first two terms have a common factor of 2x. And 2x times x gives you a 2x squared. And 2x times 8 gives you a 16x. And these two terms have a common factor of negative 5. So negative 5 times x gives you a negative 5x. And negative 5 times positive 8 gives you a negative 40. And then the first factor would be your common factor, which is x plus 8. And the other factor would be whatever is left over, 2x minus 5. Okay, so you set both of them equal to 0, which either x plus 8 would be equivalent to 0, or we have a 2x minus 5 would be equivalent to 0. And then for the first equation, if you subtract 8 on both of your sides, then that leaves you with the next value of negative 8. And in the second case, if you were to first add 5, then that gives you a 2x value of 5, and then divide by 2, which yields an x value of 5/2. All right, so these should be the two solutions for our quadratic. And let's move on to numbers 4 and 5. There's two more left. Okay, so we're given for number 4, solve the equation 10x squared is equivalent to 27x minus 18. All right, so again, bring every term over to one side. You want to subtract away the 27x. And at the same time, you want to get rid of all your constants on the right side. You add 18 for that to happen. And these terms cross out. We have a 0 on the right, which was your motive. And we have a 10x squared minus 27x plus 18 would be equivalent to 0. All right, so again, in this step, always check if we can divide every term by a common factor, which in this case we can't. So since we cannot, let's get two numbers that multiply to AC to factor the quadratic. And AC in this case would be 10 times 18, and that gives you a 180. At the same time, these numbers have to add to your B term, which is a negative 27. And these factors would be a 15 and 12. But both of them have to be negative for the conditions to work out. All right, so let's expand. We have a 10x squared, and then expand your bx term into the two factors we just found of negative 15x minus 12x. Then bring down as is your positive 18, which would be equivalent to 0. Okay, so the first two terms have a common factor of 5x, and 5x times 2x gives you a 10x squared. 5x times negative 3 gives you a negative 15x. And these two terms have a common factor of negative 6. So negative 6 times 2x gives you a negative 12x. Negative 6 times negative 3 gives you a positive 18. And these are your common factors, which that's your first factor. And the other one would be whatever is left over. So 5x minus 6. Right, so basically, if you know how to factor quadratics, then solving them by factoring is just one more step, right? You want to set both of your factors equal to 0, which either 2x minus 3 would be equivalent to 0, or we have a 5x minus 6 would be equivalent to 0. And in the first case, if you add 3, then 2x would be a 3, and then divide by 2, and x should be a 3 halves. That is your first solution. The other one would be if you add 6, then 5x would be equal to 6. Then divide by 5, and x should be a 6 over 5. Okay. Even these can be done in your head. All these steps can be skipped. In the beginning, it's okay to write some steps down, but if you get more advanced at these, get some more practice, then it's okay to skip some steps if you're sure that everything is being done the right way. All right, so last one, number 5. We're given solve 15x squared minus 3x is equivalent to 3 minus 7x. All right, so again, bring every term over to one side, combine the x's with the x's. You want to add 7x, and at the same time, you want to get rid of your constant, so subtract away 3. And these terms cross out. We have a 0 on the right side. And what do we have on the left? Let's check. You bring down the 15x squared as is, and then combine your like terms of negative 3x and 7x, and that gives you a positive 4x. And then bring down your negative 3. There's no more like terms with your constants. And let's factor. So get two numbers that multiply to AC, which AC in this case would be 15 times negative 3, and that's negative 45. At the same time, they have to add to your B term, which is in this case a 4. All right, so these numbers would be a 9 and negative 5. And let's break up the bx term into these two factors. We have a 15x squared, and then your 4x becomes a positive 9x minus 5x. And then bring down your minus 3 as is, which is equivalent to 0. And the first two terms have a common factor of 3x. We have 3x times 5x gives you a 15x squared, and 3x times 3 gives you a 9x. And these two terms they don't have any common factor. Whenever that happens, then we take out a 1. Right? So we have bring down the minus as is, and negative 1 times 5x gives you a negative 5x. Negative 1 times positive 3 gives you a negative 3. And the first factor is 5x plus 3. The other factor would be whatever's left, so 3x minus 1. All right, so now set both factors equal to 0, which either 5x plus 3 would be equivalent to 0, or we have a 3x minus 1 would be equivalent to 0. In the first case, if you subtract away 3, then 5x would be a negative 3. And then divide by 5, and x should be a negative 3 over 5. And in the other case, if you were to add 1, 3x would be a positive 1, and then divide by 3, and x should be a 1/3. And that's it. These two fractions would be the solution for number 5.